Radiographic testing, or it is another method of testing a material's characteristic. Basically, it involves radiation through its process. It is also a function of NDT, or a non-destructive testing. So now let's proceed to its introductions. Radiography uses penetrating radiation that directly towards a component. It is to measure or to acquire the material's density and thickness differences. So this is the absorption that can be recorded on film or electronically. This radiation is talks about the electromagnetic radiations. This is the radiation used in radiography testing in higher energy or certain wavelength. So there's actually two types of this kind of radiation called an X-ray and gamma rays. The general principle of radiography is the radiation affects its penetrating power. Higher energy radiation can penetrate thicker and more dense materials. So as what you can see in the image, we can easily differentiate which energy radiation has a low and high radiation energy. So from the left one is the low energy radiation image. From the right one is the high energy radiation image in terms of a thin walled area. So radiation sources. So as I said earlier, that there's the type of radiation that we're gonna get through this testing. First is the X-ray radiography, and the second is gamma radiography. So as what you can see in the image, the left one image is what we call the X-ray radiography, and then the right one is what we call the gamma radiography. So let's talk first about the gamma radiography. It, it is by the use of radioisotope. This radioisotope has an unstable nuclei that have does not have enough binding energy to hold the nucleus together. So the spontaneous breakdown of an atomic nucleus resulting in the release of energy and a matter is known as radioactive decay. And now let's talk about the X-ray radiography. So unlike the gamma rays, so the X-rays are produced by an X-ray generator system. So as what you can see in this two figure, we need these two components in order for us to use the X-ray radiography. The first one is called X-ray tube head, as what you can see in the left picture. And then in the right picture is the high voltage generator, or a console and a control console. So in imaging modalities, or this is the visual image, so we have actually 5 categories. First is the film radiography, second is a real-time radiography, third time is computed tomography, or also known abbreviated as CT, digital radiography abbreviated as DR, and the last one is computed radiography, or abbreviated as CR. So now in film radiography, this is the most widely used and oldest imaging medium in industrial radiography in a radiographic film. Its materials composed of silver bromide. Uh, the silver bromide turns to black metallic silver, which forms the image through the process of radiation. So this kind of material is what we're gonna do is to wrap it around the material that what we are going to test it on. So in digital radiography, we actually don't need what we call the film, or what we call the film. So in digital radiography, the film is not present in this process. It's purely the digital one. So there are actually a lot of forms of digital radiographic imaging, including computed radiography or CR, real-time radiography or RTR, direct radiographic imaging or DR, and then the last one is computed tomography. Now let's talk them one by one. So first we're gonna talk about first the computed radiography. So X-ray penetrating the specimen stimulates the phosphors. The stimulated phosphors remain in an excited state. As what you can see, the CR phosphorus screen structure. So this is the X-ray that penetrating through the material. So before the material, we have what we call phosphorus layers. This is the material what we are going to wrap around the material in order for us to proceed testing. This is the requirement materials in order for us to get the to in order the X-rays to operate. And real-time radiography or the RTR to this is used to describe a form of radiographic that allows electronic images to be captured and viewed in real time. So there's actually several reasons that we're gonna talk about why real-time radiography is really usable or advantageous about this one. It may be possible to image the entire components with one exposure. One exposure lang. Viewing the internal structures of the part from different angular perspectives can provide additional data for analysis. So by using this one, we can reduce the time of inspection. So this process is sometimes called the easiest one or the good one. And now the direct radiography or the DR is also another form of a real-time radiography that uses a special flat panel detector. This panel detector works by converting penetrating radiation and passing through the test specimen into minute electrical charges. This panel contains microelectronic capacitors. The capacitors from an electrical charge patterns image of the specimen. And this capacitor charge is converted into pixel which form the digital image. The computed tomography or the CT, it is also uses the real-time inspection system employing a sample positioning system and special software. So as what you can see in the picture, that's the setup what the computed tomography looks like. So we have X-ray tube and then X-ray beam that deflects the test components, and we have the image I intensifier. This image intensifier is the one that is in opposite in X-ray tube along with the PC with image capturing hardware, and then the series link turbulent interface unit analog video signal. So through this diagram we can able to compute or to use the computed tomography in order to us to detect and determine the material's characteristic. Image quality is a critical for accurate assessment of a test specimen's integrity. So there is what we call IQI. It means that image quality indicators. So this is the use these are used for this purpose. So actually there's different kinds of designs on IQI that contains artificial holes of varying size drills in metal splits, while others can manufacture from wires or different diameters mounted next to one another. So at what you can see in the pictures, that's the sample of the image quality that derived from the testing. So after the process of prediction, we need also to measure the safety before trying to consider doing the testing of this method, which is the radiography testing. There's also a regulation or the state and federal organization due to potential public and personal risk. So this radiation is not a joke, and it cause harm to the environment or to the people or even the one that manipulates the testing. So we need also to make sure it's safety procedure. If you are the one who undergo the testing, you must equip all these requirements, all these devices in order for you to proceed to the testing. First, you must have a sorbimeter. Second is packet dosimeter, radiation alarm, and the radiation badge. So these three parameters, time, distance, and shielding, this is also the means of protection to help reduce the exposure to radiation. So in time, less time spent near source, less radiation received. So it means that by doing this radiation, you don't need to expose yourself too much time in the radiation. So just avoid that one. Then the distance, greater distance from source, less radiation received. So it means from a given or from the specific distance, you must be apart from the material that you have tested. Shielding, behind shielding from source, less radiation received. So this is the sample of radiographic images. At what you can see, it is an x-ray. Uh, as what you can see, this is the sample material, the upper right, the three material in the upper right, this is the actual material. And then in the lower right, the three the right, this is the radiographic images. As what you can see, there's some internal components that related to the test. So in this process, we can able to figure out what's the components characteristics. So we can easily conclude, write, or comments what's happening on the materials that we need to improve, revise, or make a conclusion or to innovate whatever gonna be is. Radiographic images. So sample one is the scientific calculator. If you put in a test, in the picture in the left side, this is what actually looks like in the visual image. For telephone, this is its visual image. For the some fruit, this is its visual image. You can literally look into its internal component without decomposing or breaking it into pieces. So this is what it called um, the testing through the function of NDT, which is the non-destructive testing. So now let's talk about the advantages of radiography. Technique is not limited by material type or density. So it says that this kind of testing is not limited to what material it is. Unlike in PT or penetrance testing, it only required the smooth and non-phosphorus materials. So it means in radiography, all type of materials is applicable on this testing. Can inspect assembled components. So as what presented earlier, the scientific calculator, it is an assembled component, so we can able to sneak through its internal components. Minimum surface preparation required, sensitive to change in thickness, corrosion, voids, cracks, and material density changes. Detects both surface and subsurface defects, provides a permanent record of the inspections. So in radiography testing is similar to penetrant testing because these two could able to sneak through the internal components of the material. And look what look about the defects or the discontinuities of the material. And now let's go to disadvantages of radiography. Many safety precaution for the use of high intensity radiations. So in order for us to proceed the process, we need to care about the safety measurement in order for us to proceed. So this is the disadvantages because we need some more time, some more resources, some more money, and some more other thing that capable us to proceed the testing. Many hours of technician training prior to use, so you need a proper training or proper handling in order for you to get the precision and accuracy of the testing. Access to both sides of sample required. Orientation of equipment and flow can be critical. Yes, the equipment that we're gonna use is we need some expert ideas, expert knowledge that we inert in us in order for us to easy manipulate and easy use the gadgets or the devices that we need to use for testing. Determining flow depth is impossible without additional angled exposures. Expensive initial equipment costs. So this one is not friendly if I say, because radiography testing is quite expensive. We need a lot of money in order for us to do the testing. Unlike in penetrance testing is quite cheap, easy to use, and you know good for environment as well. So that's all about the radiography testing. Thank you for listening.